All right, welcome everybody. My name is Alex Kerm, and in this short video, I'm going to show you how to use the process capability tool that we've built for you in Excel. If you've already downloaded the tool or if you've accessed the tool through our website, it's free. So have a quick watch and we'll show you how to use it. It's really quite simple. So the first thing I'll say is for the process capability, you want to use this tool if you want to see how well you're delivering on your customer specifications or not. And in order to perform this analysis, there's really two main uh, prerequisites that need to be fulfilled before we can actually use the analysis. One of which is it needs to be normally distributed data, okay? And if it's not, well, then we're going to have to transform it, or we will. You're going to have to talk to your coach about how to do that because we're not going to cover that in this video. The second requirement is that it needs to be stable and predictable. The process needs to be stable and predictable. And of course, this Excel tool will evaluate both of those things and requirements for you, as well as do the process capability. So the first thing is when you get this tool, you basically, the inputs that you need to put in here is your data. Under the output column, you paste in whatever data you want. Now, I've just pasted in random data. You can go as much as you want. There's a whole bunch of stuff here. These fields will be yellow when you open it up because it wants you to put something into that field. So you paste your data in there, and right away it populates a distribution. Okay, you'll see these bars get populated, but on the right-hand side, it's performing the first little test here. It's performing a Anderson-Darling normality test. So is it the data normal? So in this case, and I'm not going to get into the statistics here, but what you're looking for is if the p-value in this box is greater than 0.05, then you can say that, you know what, for the most part, this data is behaving normally, and we can continue with this analysis. If it's less than 0.05, well, you're going to have to contact your coach because this data is not normal and you need to transform it or do something else to it before you can do this analysis. Okay. The second prerequisite check it does is right in this little graph below here. And this is a control chart where it's plotting the same data on a control chart to see and check for process stability. Now, for the most part, if these data points fall within these red lines, which are our control limits, upper and lower, we can say that the process is stable and predictable. For the most part, it looks pretty good. We have one data point that kind of falls outside there. And what's nice about this Excel tool, it actually puts an asterisk and highlights which data points have gone above the recognized control limits that are calculated based on the sample you've taken. Okay, so let's assume that everything's stable and predictable, and that data point is actually stable and in control. We're going to move on to how do we calculate process capability. Well, the key with process capability is you need to measure your process against a customer spec. Otherwise, you can't do a capability. So what you need to do is these two yellow fields here, USL and LSL, that's our upper and lower spec limits. They need to be filled out. Now, you don't need both. Depends on your process. You might have just an upper limit or just a lower limit, or you might have both. Okay, but for now, let's assume I've got an upper limit of 15 and a lower limit of 5, and go ahead and put that in there. And automatically, it now will calculate a few other values for us once I go in here. So I also need to populate my future state needs. So are the specs in the future going to be the same? In most cases, yes. You're not really changing the customer specification. Okay. So once we fill out the current state and the future state upper and lower spec limits, what's nice is that it populates now these red kind of colors on our graph. Now, it's not going to look the exact same as Minitab because it's not Minitab, it's Excel. So the way we've built this is that wherever the red lines start and to the right of it and to the left of it, these are out of spec points. So you can see that if my spec limit of the upper spec limit is 15, well, 15 is right here where the red starts, and anything above 15 is out of spec. So visually, it's showing you how much of your distribution is out of spec on the right side of your distribution. If the lower spec limit is 5, again, it's showing you how much of the distribution is out of spec to the left, and everything in the middle is kind of in spec. So what does that mean? How do we know how capable our process is? Well, all that data is right here. So the percent defective and our process capability is measured here. So if you're looking at what is our percent defective for this entire process? Well, there it is. 15.1% of the time, I'm out of spec, meaning 13.6, excuse me, 13.6 of the time I'm out of spec on the upper limit, and 1.5 on the I'm out of spec on the lower limit, with a total of 15.5 defective right there. Okay. If you want an actual Z-score or a CP, CPK, the numbers are right here. And of course, your sigma level, there you go, sigma capability, 1.6. So this process is a 1.6 sigma process. And there you have it. This is your process capability. Now, if you want, this video is yours to have, come back and refer to it whenever you want. But very nicely, we've actually put the instructions right in here as well, in case you get lost on the tool as well. So I hope you enjoyed this quick video, and it's really quite straightforward. I hope you really enjoy this Excel tool. There are a number of Excel tools that we have built to help you in your Lean Six Sigma journey. This is just one of many, and stay tuned for a whole bunch of other videos on how to use some of those other tools. All right, thanks again. I'm Alex Kerm, and we'll talk to you soon. Bye for now.